We're looking at solving logarithmic equations. Here's a logarithmic equation. Let's solve it. The first thing I want to do here is use rules of logarithms so that I have one single log on the left and one single log on the right. The good news is we already have that on the left. So I'm going to stick with my log of 2x minus 1. On the right, I can combine those together. I have two logs that are added. When we have two logs that are added, I know that I can write it as a single log and multiply their expression. So that's 3 times x plus 3. I have one log on the left, one log on the right. Same base, they're both base 10. If the logarithms are equal, then the expressions must also be equal, and we get that because logarithmic functions are one-to-one. Every x has one y, and every y also has only one x, so the expressions have to be equal. So I'll set 2x minus 1 on the left equal to, I'll go ahead and distribute that through 3x plus 9 on the right. That's now a linear equation which we can solve in the usual way. I'm going to subtract 2x on both sides. I'm going to subtract 9 on both sides. And now I have negative 10 equals x. Oh, okay. That looks done. I feel done. I have x equals negative 10. But with logarithmic equations, there's an issue with the domain. The domain of a logarithmic function is positive values only. Just because I got a negative number doesn't mean I can't use it, but it might. So we have to go back and check. I'm going to go back to the original equation up here before I did anything to it at all. And I'm going to put negative 10 in place of x. So I'm going to have log of 2 times negative 10 minus 1. Really, I don't even have to check the rest of that. 2 times negative 10 minus 1 is negative 21. I can't do that. Negative numbers are outside the domain of a logarithmic function. They don't make sense. So I go, oh no, I thought I had it, but it turns out the one candidate there was for the solution doesn't actually solve the equation, which means this particular equation has no solution.